Hi everyone, this is part 1 of the lecture to accompany chapter 11 in your textbook. Please read chapter 11, there's lots of information I don't have time to discuss. Okay, let's talk about inductive reasoning. The last 2 chapters have focused on deductive reasoning, in which our arguments are meant to prove or demonstrate that something is indeed the case. Inductive arguments are different. They don't attempt to prove something. When we reason inductively, we use evidence to support a conclusion, to say that this conclusion is likely or probably the case. Because of this, there isn't a Venn diagram or a truth table that we can create to show that an inductive argument is valid or invalid. Inductive arguments are weaker or stronger along a continuum, and the strength of an inductive argument depends on how much and what kinds of evidence is used, and how much that evidence increases the probability of the conclusion. The first kind of inductive argument we'll look at is an argument from analogy. An analogy is a comparison between 2 things in which you say that one thing is like the other in some way. When you use analogical reasoning, you're arguing that because one thing has a certain attribute, a similar thing probably has that same attribute. Let's look at a couple of examples that, while they're not very strong inductive arguments, help to see how analogical reasoning works. The first example, Bill is a Democrat, therefore his brother Sam is a Democrat. What you're saying here is that Bill and Sam have something in common, they're brothers, and that is evidence they have something else in common, they're both Democrats. In analogical reasoning, the things that have similar attributes are called analogs. In this argument, the analogs are Bill and Sam. Bill is the premise analog because the premise is Bill is a Democrat. Sam is the conclusion analog because the conclusion is that Sam is also a Democrat. The attribute of interest is the thing that they supposedly have in common, which is being a Democrat. The second example is similar. Darby is an excellent dog sitter, therefore she would be an excellent babysitter. Now, in this case, the person Darby isn't the analog. It's her job as a dog sitter, which is the premise analog, and her possible job as a babysitter as the conclusion analog. The attribute of interest, the thing that's similar, is her excellence. So the argument is she's excellent in one capacity, so she would be in this other capacity as well. So these arguments are good for illustrating the basic concept of analogical reasoning. However, they're not very strong arguments. In fact, they're fairly weak. Let's find out why. When you look critically at an analogical argument, the first thing you should look at is how similar the premise analog and the conclusion analog truly are. For instance, in the dog-sitting, babysitting argument on the last slide, how similar are those 2 things anyway? What does dog-sitting involve? Is it more or less complicated than babysitting? Frankly, I don't think those 2 things are similar enough to argue that if you're good at one, you'd be good at the other one. So the more similarities there are between the 2 analogs, the stronger the argument. Here's a modified Sam and Bill argument. Both Bill and his brother Sam are attorneys and went to the same university. Bill is a Democrat, therefore Sam is a Democrat too. So this is a much stronger argument than the one on the previous slide. There's more evidence of the similarities between them. They're brothers, they're both attorneys, they both went to the same university. Since they obviously have more in common, the likelihood that they have being a Democrat in common is also higher. Also, increasing the number of premise analogs helps to strengthen the argument. What about this one? Bill has 4 brothers, including Sam. All the brothers, including Sam, are attorneys. Bill and 3 of his brothers are Democrats. Therefore, Sam is a Democrat too. So look what happens when we include more brothers who are all attorneys and all Democrats. It makes for a much stronger argument, increasing the likelihood that indeed Sam is a Democrat. Now, it's still not 100% certain that this conclusion is correct. This is, after all, inductive reasoning, but it's a much stronger argument nonetheless. Analogs that lack the attribute of interest, in other words, they don't support the conclusion, are called contrary analogs, and obviously the fewer of those you have in an argument, the stronger that argument's going to be. In this example, Bill is an attorney. His brother Sam is not. Bill went to Ohio State. Sam did not attend college. Bill is a Democrat. Therefore, Sam is too. So really, the only similarity between Bill and Sam is that they're brothers. All the other evidence is contrary and doesn't really support the claim. So this argument is pretty weak. Now, diversity among premise analogs isn't always bad. Here's an example of a fairly strong argument. In this next example, there are lots of differences between the brothers, but the fact that the four brothers being used as premise analogs are Democrats despite their differences makes for a pretty strong argument that the fourth brother is probably one too. Bill, an attorney, has four brothers including Sam. One of the other three sells real estate, another is an unemployed artist, the third owns a restaurant. These three and Bill are all Democrats. Therefore, Sam is a Democrat too. So as you can see, they're very diverse premise analogs, but they actually create a pretty strong argument. Okay, here are three arguments from analogy. Cheryl and Denise are teenage sisters. They attend the same school, watch the same TV shows, like the same music and YouTube videos, and have many friends in common. Cheryl likes Superman movies. Therefore, Denise will like Superman movies too. This is a relatively diverse list of relevant similarities that are mentioned, so this is a pretty strong argument. Okay, here's the next one. In an experiment done at the Wisconsin National Primate Research Center in Madison, rhesus monkeys placed on a calorie-restricted diet lived significantly longer than a control group not subject to calorie restriction. Therefore, I will live longer if I place myself on a calorie-restricted diet. Now, the similarities between rhesus monkeys and humans is up for debate here, as in, do humans respond the same way monkeys do in this situation? However, this argument is stronger than one that may be based on an analogy with a species less similar to humans, like, say, dogs. And the last one, rollerblading is very much like skiing. I'm good at rollerblading, therefore I'll be good at skiing. Well, the similarities between rollerblading and skiing are closer than those of other sports like football. So this argument is stronger than a similar argument based on an analogy between rollerblading and football. Before we move on, I just want to point out that analogy is a very effective use of language that has other purposes than argumentation. Many times, analogy is used to explain rather than to argue. Comparing things can be useful when you're trying to explain something. You use the example of something else that has similar features. This can often help people understand the object or concept more clearly. Here's an example. Electricity going through a wire is like water going through a hose. The wire is the hose, amps are the water, volts create the pressure that pushes the amps through the wire, and ohms measure resistance to the flow. This is not an argument, it's an explanation. This description is not arguing that these things are similar. It's attempting to explain the flow of electricity through a wire by comparing it to the flow of water through a hose. Analogies are often used in rhetoric, which is persuasion, and we'll talk about that towards the end of the semester, which is not the same as argument, although persuasion and argument are often used together. So this analogy, bears are dangerous. If you get too close, you can lose it all. The same holds true of bear markets. In the presence of a bear market, the thing to do is the same as when in the presence of a real bear. Run. So this example is using rhetorical language to make you feel as much fear for a bear market as you would for an actual bear. So when you see analogies, look to see if they're being used as evidence for something, or as an explanation of something, or to persuade you of something. One of the hallmarks of an analogical argument is that it often generalizes from a sample. What this means is that you contend that because a certain percentage of a population that you're talking about has a particular attribute, that the population as a whole has that attribute in a similar percentage. Now, by population, we mean any identifiable group of things. Here's an example. So far, I've liked every one of Professor Hebert's lectures. Therefore, I will like all of her lectures. The population being talked about here is my lectures. And what this person is arguing is that because they like the lectures they've heard so far, that's a sample of the entire population, they'll like the entire population of lectures. In example 2, most pit bulls I've met are sweet. Therefore, most pit bulls are sweet. The population being referred to in the conclusion is all pit bulls. This person is arguing that because the sample of pit bulls that they've encountered so far are sweet, that is evidence that most, they don't say all, but most pit bulls are sweet. When you're evaluating analogical arguments that use generalizations from samples, you need to look closely at what population they're talking about and what samples they're using. If there's a question about whether the sample they're using is typical or atypical of the entire population, then you have grounds to doubt the conclusion. In this first example, every other peach I've gotten at Kroger was mushy. Therefore, about 50% of all Kroger peaches are mushy. The arguer is using as a sample only the peaches they have gotten at Kroger's, which may or may not be typical of the peaches at Kroger's. So coming to a conclusion about all the peaches at Kroger's based on your own limited sample might not be the best conclusion. I did this recently over the holidays. I got a turkey for Thanksgiving at Smith's, and when I took it out of the wrapper, it had gone bad. And then I bought some lamb chops that were off as well. And because of that, I came to the conclusion, based on those two examples, that Smith's meat wasn't fresh. So I actually stopped shopping there for a while, but it's right down the street from my house. So eventually, of course, I went back there, and I haven't gotten any bad items from the meat department since. So obviously, my previous conclusion that Smith's meat isn't fresh was based on an atypical sample and didn't mirror the entire population of meat that's available at Smith's. In the second example, the less diversified sample is weaker than the more diversified one that represents more of the population. So the first argument, I know 3 pit bulls from the same litter, they are sweet dogs, therefore most pit bulls are sweet dogs, is weaker than the second argument, I know 3 pit bulls from different litters. They are sweet dogs, therefore most pit bulls are sweet dogs. The first argument only uses a sample from 1 litter of puppies, while the second argument uses more than 1 litter to draw the conclusion that most pit bulls are sweet dogs. That more diversified sample is more likely to mirror the population. You also need to make sure the sample being used as evidence is large enough to accurately mirror the population. The example here, I don't like Jane, so I'm pretty sure no one else who knows her does either. This person uses their own feelings about Jane to come to the conclusion that nobody else likes her either. But a sample of 1 simply isn't enough to logically come to that conclusion, no matter how sure you might be of it. A small sample isn't always bad if the population being discussed is extremely homogeneous. In other words, all members of the population are known to be similar in the way being discussed. Then a small sample is okay. For instance, quality control workers don't usually measure every single item that comes off an assembly line for accuracy because they know that the things they're making are all made in the same way with the same materials. Usually a very small sample of random items are checked to make sure they're all meeting the same standards. But frankly, in our everyday lives, we're guilty of using small samples that rarely qualify as random, as I did when I concluded that Smith's meat department wasn't good. My evidence was both small and atypical, and my conclusion wasn't accurate at all. It's good practice to be more aware of the way you tend to generalize from a sample to a population. You might find you're coming to conclusions without nearly enough evidence. Remember, the strongest arguments from analogy where you are generalizing from a sample have 3 things in common. The sample being used is typical of the population being discussed. It's diversified, and it's big enough to actually mirror the population. Scientists use inductive reasoning all the time, but they tend to do it a little more differently than we do. They attempt to use samples that meet all the criteria we talked about before, and they use specific methods to ensure that their samples are representative of the population as a whole. They want to avoid a biased, skewed, or atypical sample that doesn't truly represent the population. So they avoid bias by ensuring that every member of a population has an equal chance of being in the sample. This is called random sampling. So they first create a sampling frame, which is a set of criteria that is a precise, unambiguous definition of a sample or attribute, so that they know exactly who or what is a member of that population and whether or not they have the attribute. Then they need to figure out what true proportion of the population actually has the attribute they're interested in. It's unlikely that their sample will end up being the exact same proportion with that attribute as the entire population, but they try to get as close as possible. They want to get the sample within an acceptable error margin or range, which is reported as a plus or minus number, like plus or minus 5%. The confidence level expresses the probability that the true values of a random sample lie within the error margins. If you look at Table 11.1 on page 350 in your textbook, you can see that for large populations, and by large they generally mean over 10,000, the smaller the random sample size, the higher the margin of error. This chart assumes a 95% confidence level that these percentages are accurate. So, 95% confidence level means in 95 out of every 100 random samples, where the number of things sampled equals 50, the sample proportion will be within a plus or minus 14 percentage points of the true proportion. Plus or minus 14 percentage points means that there's a 28% chance that the conclusion isn't accurate or representative of the population at large. That's a big margin of error. However, as the random sample size gets larger, the margin of error decreases, and the sample is more representative of the entire population. So 95% confidence level means in 95 out of every 100 random samples where the sample is 1,000 rather than 50 as in the last example, the sample proportion will be within plus or minus 3 percentage points of the true proportion. Plus or minus 3 percentage points means that you only have a 6% chance that the sample isn't representative of the population. So, once you have a random sample size of around 1,000, the margin of error is pretty darn small. A larger sample than that wouldn't necessarily be more accurate. That's why when big polling companies like Gallup conduct polls, they don't have to ask every single person in the country who fits the criteria for their population for their opinion, as long as their sample is representative. Statistical syllogisms are a different sort of thing. They actually look like deductive arguments, except that they're not precise. These arguments take a general statement and apply it to a specific case, as in this example. Most teachers are Democrats. York is a teacher. Therefore, York is a Democrat. So the premise analog, the population being discussed, is teachers. The conclusion analog is York, and the attribute of interest is being a Democrat. Now, the higher the proportion of teachers who are Democrats, the stronger this argument's going to be. The strength of this argument depends on what the term most means. 51% could qualify as most, but that still leaves a 49% chance that York isn't a Democrat. It's always better if your statistics are less vague, but they often aren't. So if 80% of teachers are Democrats, that's a stronger argument. 90% is even stronger than that. So evaluating the strength of this argument might mean doing some research about how many teachers are actually Democrats. Statistical syllogisms are used all the time, and they generally are formulated like this. A certain proportion, the actual proportion might be stated, but it's just as likely to be most or lots of X's are Y's. This thing is an X, therefore this thing is also a Y. This is the end of part 1 of the lecture on Chapter 11. Please move on to part 2.